3D printing can be used to create anything from simple prototypes to in-use parts that go into consumer goods, medical devices, vehicles, industrial machinery, and more. Different 3D printing technologies are suited to different applications, and one of the most important determining factors is the availability and performance of materials. In this video, we'll compare the materials offered by the three most common 3D printing technologies for plastics: FDM, SLA, and SLS. FDM 3D printers melt and extrude thermoplastic filaments, which a printer nozzle deposits layer by layer in the build area. The most popular FDM 3D printing materials are PLA, ABS, and their various blends. PLA is ideal for printing concept models and looks like prototypes in a variety of colors, but it tends to be quite brittle. ABS is a higher performance alternative that is tough, durable, and heat-resistant. However, it is incompatible with some FDM printers because it requires a higher bed and nozzle temperature than many low-cost printers can reach. Additionally, printing with ABS requires ventilation because it produces VOCs with a strong odor that can be harmful if inhaled. PETG offers a good compromise between strength and workflow and can be semi-transparent. If you're looking to print flexible, stretchable parts, TPU is a great choice for printing simple designs, but on FDM printers it is prone to failure from clogging, stringing, and moisture absorption. Some FDM printers can also print with engineering plastics like nylon and specialized composites like carbon fiber-filled plastics. SLA 3D printers use light to cure thermoset resins into hardened plastic in a process called photopolymerization. Resins are uniquely formulated as opposed to the industry standard thermoplastics used in FDM and SLS 3D printing, so the availability and performance of specific materials vary greatly by brand. General-purpose resins are ideal for printing high-resolution models and prototypes with a smooth surface finish. Resin printing is also the only 3D printing process that can create truly clear and transparent parts. For engineering applications, there are a variety of strong and functional materials with properties similar to ABS, polypropylene, and other common plastics. There are also glass-filled materials for rigid and exceptionally stiff parts, offering heat resistance to more than 200 degrees Celsius for advanced applications like molding. Flexible and elastic resins are available to create parts with the flexibility of rubber, TPU, or silicone. SLA can print softer elastomers than either FDM or SLS, achieving a sure hardness durometer as low as 40A. For specialized applications, there are a wide range of biocompatible medical and dental resins, as well as castable materials for industrial investment casting or jewelry casting. Lastly, polyurethane resins are production-grade rigid and elastomeric materials for durable, long-lasting in-use parts. SLS 3D printers use a high-powered laser to fuse small particles of thermoplastic powder, creating parts with excellent mechanical characteristics. Of all the polymer 3D printing technologies, SLS gets the closest to the performance of molded or machined plastic parts. The most common SLS 3D printing material is nylon, a popular engineering thermoplastic that is lightweight, strong, and ductile, as well as stable against impact, chemicals, heat, UV light, water, and dirt. Nylon 12 is the most commonly used SLS material that is ideal for the functional prototyping and in-use production of complex assemblies and durable parts with high environmental stability. White nylon parts can be dyed in custom colors. Nylon 11 is a more ductile nylon material with higher elongation at break and impact resistance, but lower stiffness. Nylon can also be reinforced with other materials to boost its performance, such as glass for rigidity or carbon fiber for lightweight and strength. As an alternative to nylon, some SLS 3D printers can print polypropylene parts for works-light prototypes and durable in-use parts that are chemically resistant, weldable, and watertight. SLS printers can also create flexible TPU parts with unmatched design freedom and ease. TPU is an elastomeric material balancing high elongation at break and superior tear strength that is ideal for functional prototypes and end-use parts. To choose the right material, first, define your performance requirements. Plastics used for 3D printing have different chemical, optical, mechanical, and thermal characteristics that determine how your 3D printed parts will perform. Next, translate them into material requirements or the properties of a material that will satisfy those performance needs. You'll typically find these metrics on a materials data sheet, which you can compare with the specs of materials produced by traditional manufacturing processes. In the end, you'll most likely end up with a single material or a small group of materials that could be suitable for your application. From there, you can weigh other key factors. Check out our other videos on print speed, cost, quality, and ease of use to learn more.